Back in Lab 12 or Worksheet 6, we looked at Fletcher machines. And if you remember the important thing I said about your Fletcher machine, to make sure you have a level desk and we're pulling this block with a level string that had another weight hanging off. Well, that was important because we wanted to make sure that the angles didn't interfere. But this problem now, we've got a ramp with an angle of 30 degrees and a block being pulled up at that angle. And we need to find the coefficient of friction. So here we are. So I've got my 30-degree angle. I've got my block of 750 grams being pulled upward with the green rope here. It's a weightless piece of rope. We have a weightless, frictionless pulley at the end here that just transfers the motion to this other 900-gram block. And what we need to do is we need to figure out the coefficient of friction. Okay, so let's remember that we have a force of gravity on both of these weights, and it is straight down. And once again, as always, I'm going to suggest anytime you have masses, find the force of gravity for each one. So the block that's moving here has a mass of 750. Its force of gravity is 7.357 newtons. And this block over here has a force of gravity 8.829 newtons. Okay, we need to remember that there's a force of tension here in the string, and that force of tension in this problem is going to be equivalent to that second force of gravity. It's that 8.829 newtons, which is the same as this force right here. I'm going to call this my applied force, which is different than the last problems we were solving. What do we have? Well, moving downward, we'll have friction that is opposing the movement of this object. But we're also going to have a second force, which I'm just going to leave it called our parallel force. So we have these two forces here. And we need to compare those two forces to this applied force. If the parallel and the force of friction equal the Fa, then we'll have a net force of 0. It is not accelerating, it's moving at the exact same speed. So if it's stationary, it's going to stay stationary. If it's moving, it's going to keep moving at the same speed if the Fa equals these two forces combined. If the Fa is bigger, then it will accelerate up the ramp. If these two forces are bigger, then it'll still move up the ramp, but it will get slower and slower and slower until it comes to a stop. So we need to compare these to get our F net. Don't forget, we have a natural force there, which is equivalent to our perpendicular force here. And then I haven't drawn in this last one, which is my parallel force there. So there's all the forces that are working on this object. And there's a lot. So let's see if we can figure out what our coefficient of friction is in this problem. Well, we know that our force of tension, which is I'm calling the applied force in this example, is 8.829 newtons. So what I can do is using our force of gravity number 1 here, I can quickly find my Fn. Remember, my Fn is the same thing as my perpendicular. And if you forget, you can go back to the last video, our Fn is going to be equal to the Fg times the cosine of the angle. And this angle right here is equivalent to that 30 degrees. So we can find our Fn very quickly. And that is going to be 6.3718 newtons. So once again, that's the perpendicular force downward, which is equivalent to that natural force pulling perpendicular to the surface of the ramp. We can find our parallel, and that is going to be the FG times the sine of theta. And in this example, our FG times sine theta is going to be 3.67875 newtons. Now, we were told that the block moved at a uniform speed. So because it's moving at a uniform speed, what we know is that force of tension, or the FA, okay, we have an F net is 0. So our FA is equal to the parallel force plus our frictional force. I'm going to cross this out. So our FA equals our parallel and our frictional force. And so what we can do is we can take our FA, subtract our parallel force, and that'll tell us our frictional force. So in this example, our FA was 8.829 newtons. And we're going to subtract our parallel force of 3.6875 newtons. And this will give us our frictional force for this problem of 5.150 newtons. Now that I know my FF and my FN, I can easily find my coefficient of friction. So that would be 5.150 newtons divided by 6.3718 newtons. And that's going to tell us that our coefficient of friction for this problem is 0.8083.